go along. Good afternoon, all. This is Josh Hertel, Director of the School of Data Science. I'm very excited to have you all here. I'm very excited to also have Tom Fisher, not only top advisor to SAS and Dr. Goodnight at SAS, the founder of SAS, but also a UNC Charlotte alum, and Alex Guh. Alex, am I pronouncing your last name correctly?
Yep.
Okay, just want to make sure. We're going to get started with our conversation talking about a day in the life of data scientist and SAS in a moment, but I wanted to remind you all, this is a regular Wednesday event. Next Wednesday, we will have SIA Partners, which is an international consulting firm. For many of you, this is going to be a particularly practical and useful session. They're going to start a little early at 3:30, and it's looking at getting hired, working a resume in the time of a pandemic. What we've been hearing from a lot of our partners is that you all have phenomenal experiences, but oftentimes you could use a little help with tweaking the resume and making sure it's speaking to the right audience. So if you want that opportunity, please go ahead and sign up. You can find it on the data science website. Go ahead and sign up and join us next week. We'll be excited to have that as well. Also, for students in the graduate program, you should be getting notices now about the upcoming advising sessions for registration for, believe it or not, the spring semester. We're already there and getting plans and ready to go. We will also be sending out a notice to students in the HIA and the DSBA program about a special internship workshop with Doug Haig and Dr. Susan Odom to talk about some of the ways that you all can prepare expectations for the courses in the health informatics program in the DSBA. And with that, I'm done with my commercial announcements, and I would like to turn it over to Tom Fisher to go ahead and kick us off to talk about a day in the life with Alex Guh of a data scientist. Thank you all for being here.
All right, well, I'm going to share my screen. Can you see that okay, Josh?
Yes, yep.
So I'll give a little bit of a commercial for SAS. For those of you who are not aware, SAS is based in Cary, North Carolina. It's the world's largest privately held software company. We have about 44 years in the world of business analytics. Dr. James Goodnight, the founder of the company, happens to be the wealthiest individual in North Carolina, founded the company 44 years ago, back in the days when he was a professor at State. We have 14,000 employees worldwide. Our products are used in 91 of the top 100 companies on the Fortune Global 500 list. One of the things that you'll find about us is we're in the process of really redefining ourselves and really taking the position that we feel like we deserve, which is as the leader in advanced and predictive analytics software. As you can see, IDC rates us the leader with 30.8% of that market. We're ranked one of the top 10 great places to work for the past 12 years. I think that's probably one of the things that in North Carolina SAS is best known for. We reinvest about 26% of our revenue back into research and development, because at the end of the day, Dr. Goodnight thought from the very beginning that we should continuously innovate. And in order to do that, customers typically will sign a single one-year contract with us, and it forces us to continuously innovate to deliver new and greater function for our customers. We have 146 customers in 146 different countries, and we have over 80,000 sites worldwide. As Josh said, I'm Tom Fisher. I'm an alum of UNC Charlotte. Long before any of you were ever born, I was going to school there. I started my career in analytics working for the governor of North Carolina. At that time, it was Jim Hunt. And that's my first experience using SAS, because SAS was still at NC State being used internally. And it became my responsibility to do statistical analysis for the governor of North Carolina on a number of his different policies. Since then, I've gone on. I was the chief technology officer at eBay. I was head of eBay. Then I went to Qualcomm, where I ran the semiconductor engineering teams. I left Qualcomm and joined a company called SuccessFactors, which was one of the first companies to arrive in the cloud. When I joined, we had about 3 million subscribers. When I left, we had 38 million subscribers. After SuccessFactors, I joined Oracle and was the CIO for our cloud, global cloud initiatives for about 8 years, and then left Oracle to join a small startup called MapR, which was acquired by HPE. I've retired probably 3 times. I retired before joining SAS. And then as I was in the process of considering moving back to North Carolina, because I've been in Silicon Valley for the last 15 or 20 years, so I've lost my North Carolina accent. During that period of time, I was recruited by SAS to join as an executive advisor to Dr. Goodnight and Dr. Oliver Schabenberger. Today, my responsibilities include the labs, which is what Alex is a part of, which is the advanced technology. We like to refer to ourselves as the tip of the spear for analytics, because we do a lot of advanced work that Alex can talk further about on behalf of our customers. Well, I'm also responsible for our global hackathons, which we have run one successfully, but we want to make this an ongoing regular feature with the goal of identifying subject matter experts and new data scientists with new ideas to build their products on SAS. And then it would allow us, if the product has the right addressable market and aligns with our overall strategy, to take those products to market on behalf of the entrepreneurs that create them. So Alex works on what we are internally, well, actually it's an external name, it's called our Vector Labs. It's a global organization. We're based in Singapore, we're based in Cary. Alex is located in the Bay in San Francisco, so we're in Silicon Valley as well. We have a lab in Sao Paulo. We have a lab, well, we just have labs all over the place because we're SAS. But I'll let Alex introduce himself. But the goal of this session is really to take you through what you might call a day in the life of a data scientist, but we'll talk about topics beyond that. So Alex, you want to introduce yourself?
Great, thank you, Tom. And a little bit of background about myself. So as Tom mentioned, I am a data scientist under innovation lab based out of the San Francisco Bay Area called SAS Vector Labs. My background going further back, so I did my undergrad in applied mathematics up in New York at Columbia University. And from very early, one of the tangents to applied math that I was interested in was biostatistics. And so I did research under PI for quite some time. We worked on a project to process gene expression data on this now sort of outdated technology called DNA microarrays. And so essentially these are these chips, right, that you put samples of tissues or whatever on, and it can measure how often a certain protein is expressed based on the mRNA present in that sample, right? And so so that was sort of my first foray into statistics and into machine learning. I worked quite a bit with R. I used R to process the data, to normalize the data, to clean it up. Now, the sort of around the time that I went to Columbia, this was the time that Python sort of started to become more widely adopted. And so a lot of the trend that was happening around then was, classes that were traditionally taught in MATLAB, for example, we started to not use MATLAB anymore, which is you have to have a license for, and it's a language, and we started to use Python a lot, and so so I picked up quite a bit of Python in college, which really helped me out quite a lot here when I joined SAS. So I joined SAS in 2016 out of college. It turned out that joining this great company based out of North Carolina paid a lot more and had much better amenities compared to doing research at the time. So that's the decision that I went with, and so there I was in Cary, North Carolina for the past 4 years, and then recently I moved to San Francisco, being based out of the Bay Area now. But the reason that I mentioned Python in particular and how it became to really be widely adopted around the time that I was in college was that around the time that I joined SAS, knowing Python and being part of the transformation that SAS is also undergoing and working with open source interfaces like Python and R was tremendous in the type of work that I did here. Quite a lot of it, working with Python in addition to other open source languages. And so, so that's a little bit of background by myself. I'll hand it back to you, Tom.
Okay. Well, what we wanted to try to do was take you through some of the challenges, some of the current trends and tools and technology that exist in data science. And this is going to be a question and answer format because Alex and I have worked together probably for about, 6 months now. So we don't know each other very well. So I'm going to start with some basic questions. Are there different types of data scientists, Alex?
Absolutely, absolutely. So let me start by talking about generally what can be consistent across most data scientist roles within different organizations. So the first area is going to be doing some type of statistical work, whether that is testing, whether that's designing experiments, or some sort of predictive modeling. So these are sort of pretty typical tasks for data scientists across different organizations. Here at SAS, so if we think about who are my customers as me as a data scientist, I have customers internally from within SAS. So these are our marketing sciences teams working with them on lead generation projects for our sales teams. These are building sort of software and packages with our R&D teams within SAS. I also have external customers that I work with, and this would be the clients of SAS. So this would be working with clients to design and build end-to-end machine learning workflows from data ingestion to model deployment. So sort of along the predictive modeling, you could have this is like a pretty typical role for data scientists. Another characteristic I think of that defines what a data scientist does is communicating is huge as a data scientist. Being able to communicate with stakeholders, those people who are your customers, right? If you think about it in that sort of frame, being able to translate their use cases from a business side into a technical side, and being able to own that sort of project, communicating with them about, what is this model that you've built really means, explain to them how that works in a language that they can understand, being able to offer guidance on how does this influence the decision they should make, right? And then I think the last thing that is common probably among all data scientists now, if we look at the trends in the market, is being able to write good code. And this goes whether you are a R programmer, whether you're a SAS programmer or a Python programmer. Or probably across most data science being able to write SQL, right? It's something that is really important, and a lot of people look into is being someone who can write good code, write clean code that can be used in production. One of the things that I pride myself in is being able to write really good code in Python, Java, and C++. I'm always sort of keeping up to date with the latest developments, the latest packages that are being used in the data science world in Python. So it's programming is sort of like creeping into sort of a bigger and bigger role for data scientists as we move into the current and in the future.
So let me ask you a fact or fiction question, Alex. In the world of domain, it's been a while since I was did data science. So my skill set goes back to like Zeppelin, which was a precursor to Jupiter
Yep.
But what I found is that data scientists spend about 80% of their time working with the data, trying to get the data in a format or in a understandable format that can be used for analytical purposes. Is that a true or false statement?
That's absolutely true. And I think the biggest lesson that the biggest theme I would say that I've learned in my years as data scientist is that the tools and the algorithms are really just a small part of what data scientists do. Oftentimes, even, without getting to cleaning the data, to massaging the data, right? Sometimes you have trouble getting the data. So you're talking to your data engineers, you could be talking to the IT to get access to some data. Someone could come to you and say, hey, like I want an answer for this thing, and then you need to go be able to get that data first to actually work with it. And then, in terms of actually doing the data transformation, I think it's important for data scientists and to be proficient at least one tool to work with the data, whether that's SQL or whether that's pandas. Just being able to use one of those tools to essentially transform the data, work with the data to get into something that you need to actually apply the models. So I think that's absolutely true when people say that, a large portion of the time is actually spent on the data.
So when you dig into the data, one of the things that I've been following is I've tracked MIT pretty closely, and there's this whole notion of there's bias in the data, in the data, the source of the data. What does that mean? And is that a good thing, a bad thing, or is it something that you just have to understand as a data scientist and work around?
Sure. Yeah, I think one of the examples I like to that I follow and I quite like to use is this. And this is a project that I also worked on. But just when we look at bias inherent in AI models, like for example, doing facial recognition, and when we talk about when we think about bias in data, that could mean a lot of different things. The bias could come from just the characteristics of the data set. If we look at, for example, if we train a model to differentiate between two faces, right, to see if they're the same person. Well, if the data that you train the model on is like 80% of like one type of person or one gender or even, then it's going to be underrepresented if you introduce someone who is not prevalent in that data set. So the model is not going to be able to discern between those sort of faces as well as the samples and the training data that it has seen. So this first category, what I'm trying to get at is, the sort of overrepresentation and underrepresentation in the different classes you have within your data set. And this, it could just be an inherent case of, collecting the data and how the data is collected. But essentially, when a model is applied on that, the model is not inherently biased. It's just that it's learning based off of the data that you feed it, which can be skewed, right?
Now, you talked about training models. And one of the questions that I always struggled with was, how do you version those models? I mean, and by the way, in my experience, I always kept the old models running so that at least I could trend how well I was doing or if I was improving or not. Is that still the case today?
It is. And I think versioning can be pretty different depending on which team sort of you work on. I think a trend now that we see is that a lot of data scientists are moving their work into some sort of version control system like Git. So, Git being traditionally used to version code bases for developers. But now, now that, much of our work, data scientists work is based on, writing code and, building models with, for example, writing a Python script to train a classifier with these certain hyperparameters, all that is versioned sort of using Git. And so if I want to change my model, if I want to update it, I create a pull request that gets reviewed by my team, and then that gets tagged as like a certain version or certain release. We also see, but that is only sort of like one way of versioning models. From a code perspective, there's also sort of if you think about all the different assets that gets produced from the code, this could be in the context of Python, a pickle file, or it's like how you save your models into a certain binary file. This could be metadata. This could be sort of JSON that describes the different environments, the different inputs and outputs, the variables about your model. So when you start getting into all of these different sort of assets that need to be packaged along with the code, that's when you get into tools like, something that we use here at SAS is a SAS model manager, right? Where that's something to kind of describe it is where you package the score code along with all of these different assets into an application where it's able to keep track of the version, is able to keep track of the current champion and challenger. So that is one sort of application that can sort of version this. A lot of teams may roll with their own like in-house sort of method or way to deal with that, but it's certainly not a very cohesive or very standardized approach when it comes to managing like models and versioning them in general.
So when we talk about at SAS, we talk about end-to-end analytics. I'm assuming that as a data scientist, you're there when they're formulating or trying to articulate what the business problem is.
Yep.
Determine what sources of data to go collect information from and what tools to use.
Yeah, and that's often the case of how it starts out. Someone will, if you're a data scientist, someone will come to you with a problem, or they want some sort of answer. And oftentimes, right, like we as data scientists, we have to sort of push back on some of the expectations. They may come with like a completely unrealistic thing. They want like this problem to be solved like in a perfect world. That could be possible, but we have to, part of our work as data scientists is to sort of bring their expectations down to reasonable reality where we can sort of help them solve their problems, but also not sort of expand the scope of what the expectations are. And so, again, like we're limited by the data we have access to. We're limited by real world factors, right? Things are not perfect in the real world. So one of the things is, oftentimes when we start out these projects is to sort of, again, like scope the problem and then determine the requirements and sort of go from there.
Now, do you use a technique like CICD in data science, continuous innovation, continuous development, assuming that the model is going to continuously be iterated over time? Is that the assumption that you go in?
Yeah. I would say CICD is sort of the end goal, the holy grail, right, of where every organization wants to strive to. Ideally, as a data science team, you want to be able to produce a new model and have an automatic pipeline that runs the testing, the code checks to make sure everything runs fine, and then to deploy that into the stack, whether that's a database or an application. That's the end goal. I think a lot of people are not quite there yet. I think a lot of even teams that I work with, CICD is still something that they're trying to move to, and currently it's just like a cron script or some sort of batch job that gets run on a schedule, right? But certainly CICD is where the trend is going towards.
Now, as I mentioned, you're working on some of the real advanced technologies that are coming out into the marketplace. One of the things that I try to talk about, but probably don't do a good job of explaining, is the integration of analytics into application through a means of orchestration. Can you give us an example? Because I think that's the direction that data science is going to head in, is integrating the work that the data scientist does directly into the applications to affect the outcome of the application with real-time or appropriate data, right?
Yeah, absolutely. That's absolutely I would say the value that data scientists are gradually moving towards, is being able to leverage the work that they do directly into the ultimate applications. Whereas before, like it could, whatever model that you as a data scientist build, that gets handed off to the data engineers, right? They take your model, they pick it apart, they deploy that in some sort of SQL job in a database that gets run. But now we're looking at, with the move to cloud and the advent of CICD, we're looking at things in the stack like being introduced, like Docker, like containers, whereby your model gets published into a container that contains all of the dependencies for your model to run, and that gets scaled through orchestration tools like Kubernetes in the cloud. And then the model that you build, that gets exposed through a contract with the application via an API. This could be a REST API, this could be over RPC, but that sort of like seamless integration is where I think a lot of companies are moving towards now.
Now, is there a difference in real-time analytics versus a traditional data science job? I'm thinking about streaming data and running analytics off of streams versus what I've traditionally always thought of as a batch job. Is that more prevalent? And what kinds of tools do you use there?
Yeah, it is. It is slowly getting more prevalent. I think, however, when people talk about streaming analytics, it tends to be sort of a little bit behind what we do traditionally. So by that, I mean, a lot of people, when they do streaming analytics, they're still doing quite simple things like being able to do filtering, being able to calculate statistics on a moving window in stream, being able to essentially cleanse some of the data before it lands in a data lake somewhere. So that is sort of most of what I see when it comes to streaming analytics. Of course, there are beginning to see sort of ML and models being deployed in stream. And this is where we see technologies like our SAS and stream processing being able to put a model actually in streams doing inference in real time. This could be, for example, an object detection model on an incoming video feed. One of the startups that SAS we worked with, based out of the Netherlands, SciSports, one of their tasks is to track soccer players during a soccer game. So to understand, how a player moves, which sort of areas he's covered. So those have to be done in stream, right? So in order to actually realize that sort of goal, you have to deploy your object detection model in stream. You have to use a streaming engine like Kafka or event stream processing in this case, and then publish those results in real time.
Now, do you see the use of data science being applicable outside? I've always thought that in order to be an effective data scientist, you needed to be a subject matter expert in the area that you were working in. But it sounds like with tools and data feeds, that's having that core subject matter expertise is less incumbent on the data scientist and more incumbent on the person that in the business organization that you're interacting with. Is that true?
Yeah, I mean, I think so. I think like nowadays, when you look at companies hiring data scientists, they're not hiring data scientists based on the fact that they've done work in that particular domain, right? They're looking for someone with the general set of skills who's able to look at a problem, ask the right questions about how do we break this problem down? What are the things that we're missing? What are the questions we need to ask in order to get the answers from this data? So you're looking at general skills like being able to use some sort of tool to manipulate the data so you can get the answers. You're looking at some sort of tool that you're proficient with to do some basic visualizations, do some plots and be able to support these sort of conclusions that you're sort of making. So I think in general, having just those critical thinking skills and having those skills to be able to work with these tools is more important than having particular expertise in a domain.
Now, you said something early on that kind of intrigued me about communications being so vital as a data scientist. Is that because most times the subject matter expert may have no idea what you're going to do, but in order to get them comfortable with, the work that you're doing, they need to be comfortable with who you are?
It's a little bit of both. I think for people who are not down in the weeds in terms of doing data science, they sort of see data science as sort of like a cloud that encompasses so many things. So if when we think about data science, right, like we think about in terms of first of all the data engineering part. How can we what kind of data we have access to, and then what are the skills that we can actually apply to this data, whether that's basic statistics or optimization skills, forecasting, machine learning. But from someone outside of that umbrella, they're just thinking like, oh, we could just to give like a really example that's really out there, but it's like, I expect you to be able to build a model that can tell me, track where this person is going and be able to differentiate this person from 20 other people on the same sort of frame, and being able to do that in real time. There's like so many layers to that, right? Like so many requirements that are really different things when it comes to like what data science we're working with. And then on the flip side, communicating is also about sort of when you're working with these stakeholders, being able to explain these limitations, being able to explain like what this model can determine, what this cannot determine. Just because the model says this doesn't mean that that's the end, right? We got to be able to explain why is this model giving this decision. It's very important in some highly regulated industries like banking, for example, being able to explain why a particular model like approves or denies someone for a loan. You have to be able to explain these individual factors, and that's really what the stakeholders care about, right? Is they don't care about the fact that you use this really fancy model or regression. It's that being able to understand like why certain things are happening. So that's the really important part of communication.
Now, you've talked about data scientists and data engineers. Are those two different roles, or are they frequently, when you're coming into the world or joining a company as a data scientist, they expect you to do data engineering? And what is involved with data engineering?
So they are different roles. However, it's quite common that sort of the lines kind of blur a little bit between data engineers and data scientists. The role of a data engineer, and generally speaking, is to work with the data and meet the requirements that a particular company may have with the data. To give it a really broad example, you could be some sort of company, you have a bunch of subscribers and data about these subscribers. Well, if a customer decides to hit unsubscribe from a monthly email or whatever letter, there are regulations that say that you have to remove their data within a week or something. It has to be removed from your database. So data engineers have to build these pipelines to do these things and to be able to create the tables that data scientists end up using to do visualizations and build certain models. Now, a data scientist, when I say like it's kind of the line has been blurred a little bit, is because in order to sort of be productive and sort of get somewhere in your work as a data scientist, you have to have some data engineering skills. And so that typically is thinking in terms of a data engineer, like thinking in terms of if your data is a table, what kind of joins, what kind of queries can I run to get this shape of the data. Being able to understand, that the database you're connecting to may not, you may not expect to be able to, load all like the entire gigabytes worth of data into your environment, you have to sort of understand the technicality of the data stack a little bit to be really proficient at your work as well.
So one thing that I see happening a lot is companies will start building their data models, and they'll be using their own internal data. But in order to make their models more accurate, or they'll sometimes need external sources that did not come from them. What's the procedure that you go through, particularly if you're in a very, very regulated industry like banking?
Yeah, that's a really, really interesting topic. And I think that is an area that is being actively explored right now. I'll give you one example of how that is sort of working in terms of data sharing between different companies. Like you said, one company may have a certain set of data that is valuable to them, but ultimately it could be in the interest of two companies to sort of share their data and benefiting both of them by making the model better. And so, in some industries, this is very hard to do because of laws around PII, and it's hard to sort of share that data directly. But what can happen is, company A may have built this model, and so this model, was trained on this data. Essentially, this model is a bunch of numeric coefficients and weights, right? So instead of sharing the data itself, it's kind of possible to do sort of a transfer learning approach where, we share this model with the weights that are sort of calibrated on the data. And then I give this model to you, and you take this sort of warmed up or pre-trained model and then fine tune on your own data. So now the model sort of has seen and trained on both sets of data without actually, sending the data over. So that is an interesting thing that is being explored in some of these frameworks. If you guys have heard of TensorFlow, which is a framework used to build these really large networks with millions of weights. So there's some modules like TensorFlow Privacy that is sort of exploring how to do this effectively. But I think that is a very important a very important topic, and I think it's just beginning to explore how that's being made possible.
Now, what's the role of the cloud? I mean, typically most people think of it as infrastructure as a service, but you have unique insights into some of the cloud services and the roles that they can play, and some of the things that you need to be careful about before you sign up for an Azure or a Google or an native cloud service. Can you talk a little bit about that?
Sure. I think the cloud has, in some ways made our work easier, and in some ways made our work more difficult, because I'll say it's made us work easier because now, if you think about what's possible from a data science perspective, the tools that you have access to now, being able to spin up a Jupyter server that is running with GPUs on the back end, that's running with 64 cores, 256 gigs of RAM. You can have that up in a few seconds, just being able to start that on a cloud server. I would say it also makes it a bit more complicated now, because now when things are in the cloud, you have to think about where your data is, right? Because if your data is not co-located, if it's located somewhere else, you can have performance issues because you don't want to be sending a bunch of data back and forth. So those are architectural considerations. And then of course, with the cloud comes a bunch of sort of new cloud technologies that you're constantly having to adapt to. And this is working with technologies like Docker. To just give you an example, now when I do any sort of work with again TensorFlow or PyTorch or different sort of frameworks, instead of having that all installed on my local laptop, I use Docker almost all the time, because when you have so many different packages and technologies together, using Docker makes it easy to keep them separate and not have conflicts among the different software. So sort of it adds a bit of complexity, but I think there's also a lot of benefit with everything sort of moving more into the cloud.
Now, there's a lot of discussion around open source and open source technologies. And, you know, at SAS, we were the first ones to say, no, we don't need open source. You don't need open source. I think, you know, you and been playing a role of gradually seeing open source introduced into SAS as instead of a competitor, as something that we can cooperate and collaborate with. And I know you've done some work with R, Python, and also the SAS model manager. How different are those models? How do you make the decision on which one to use?
Sure, that's a good question. Open source is like it's huge, right? It's only going to get even more sort of commonplace. The explosion. I think Python has been a really big driving factor for open source and data science, as well as R. Again, because of these tools and packages that are being open source that anyone can pip install and then start working with it. And then you have a lot of companies like Google, like Facebook, who build these like frameworks and then open source it. So they're not in the business of selling these tools. They're in the business of having data, and they open source these tools and give everyone the choice to use it. And what that does is it builds a community around these tools, and ironically it invites more contributors. So more people contribute, and these tools become even more popular. In terms of the differences between open source models or tools and like something you would for example use from MATLAB or from SAS, of course there can be small differences. A decision tree that is implemented in SAS can be slightly different than the algorithm that's implemented in scikit. They probably share a lot of the hyperparameter settings, things you can sort of do equivalently, but ultimately the algorithms are going to be a little bit different. But I think those are not the things you're sort of necessarily looking for when you're building a decision tree. You're looking for the type of model, not necessarily the small differences in the implementation of these two models. And that goes between the open source tools as well. Like the decision tree in scikit is going to be a little bit different than the one in R. It's going to be a little bit different than the one that's implemented in Spark, Apache Spark, and MLlib, for example. They're all going to be a little bit different. But again, it's the choices you make when, for example, if my data is big enough that I need a distributed sort of, it's not going to fit in a Python runtime on a single desktop computer. I need to use something like Spark or something like SAS to build this model in a distributed manner on large amounts of data. That's sort of those considerations I think are more important in driving what tools you ultimately end up using.
Now, one of the things that I find difficult to do the correlation, but is there a correlation between model development and business use cases? And then when you do something for a particular business use case, do you find that you can use that same model in another area, or is it very definitive to the specific use case that you're driving at?
And Tom, just to kind of throw in, we're getting towards that last 15 minutes. I want to, if we can, get some time for questions from students.
Okay.
Maybe we can slip it in after this.
Okay.
Yep. So I think I'll answer that question with a example from Kaggle. So as most of you are familiar with, Kaggle is a website that hosts data science competitions from a wide range of problems. They have a lot of different types of data sets, a lot of different domains that these competitions gets posted. But I think you do see a lot of similar techniques and models that are used across domain, across problem types. And this is like things like XGBoost, super popular. Like a lot of winning solutions use some form of gradient boosted trees. You see techniques like ensembling and model stacking being used pretty much like across, no matter what really the problem is. Like, these are sort of like the tried and true things that will get you to a very good result very quickly. So yeah, I think you do see sort of that reuse of different models and techniques across different business problems.
Josh, got it?
Yep. So one of the questions we had was essentially what makes a good data scientist, and you've touched on these. You both touched on this a little bit, but what are those 2 or 3 characteristics, skills that you look for that you say that person's got a future, has got an opportunity, fits in this model?
Right. Yeah. That's a good question. So I think the one of the major ones that we touched upon was communication. And this is communicating effectively to a diverse audience, right? Not just to your fellow data scientists, but to people like developers and application engineers, because you need to talk to them to productionize your model, to deploy your model. This is talking with business people who are those people who are coming to you with certain problems. This is talking to executives who want to understand how a certain model will impact ultimately the business, and what kind of impact that can have. So these audiences can be large and small. It can be sort of like communicating in person. It could be to an entire team of who has very little idea of what the data scientist does, right? And I think another aspect we touched upon was being skilled in at least one language. It could be anything. I don't think there's an expectation for data science for across many companies. There's really not an expectation for someone you have to know this. It's more of like you have to at least be good at one language, choose one language, one package that you can be really proficient in. And then lastly, I will add that you should be good at the fundamentals, because and this comes back to being able to look at the basic statistics, being able to use that to support a conclusion, or being able to support a decision that you made. And ultimately, I could take a data set, throw that into XGBoost, and get some sort of model. But if you don't have the sort of the fundamentals to sort of support that, it's going to be hard to defend for example, to an executive, like why is this model doing this? And then you can say like, oh, well, this is you being able to explain your process for developing that and why you chose this model and things like that.
Swathi's asking a question about career paths. What's the best career path for data science to aim for? I'm going to modify it a little bit to say, I think maybe to clarify a little bit, to say like, if you're somebody coming straight out of an undergraduate program in data science or a graduate program in data science, what does that first job usually look like? What's that path? And maybe that can be kind of a reflection, Alex, for you specifically.
Mm-hmm, sure. Yeah. So the range of that path can take shape in, I think, several different ways. Sometimes some companies, when you join, you will be attached to sort of a product team, for example, and you will be the data scientist who will be sort of working primarily with the product managers, with the business side, the analysts and the developers for that particular product. And so that's you'll be sort of in that sphere. Sometimes as a data scientist, you may be sort of on a team that generally supports across the business. So you could be part of like a central data science team that different divisions or different business stakeholders will come to you for problems, and your team will be the ones to engineer those data pipelines to solve those questions from the business side. Now, initially, when you first start as a data scientist, you probably will be tasked with some more low-hanging fruits, things that involve working with the data, working with things like SQL, and building out maybe those basic analysis reports and visualizations. And again, it could be like the experience could vary, but essentially when I from my personal side, when I joined SAS, it was sort of getting warmed into my job by sort of handling those more data related tasks at first, and then later on working into being able to manage bigger projects from start to end.
Got a question from another question from Lavidia. I hope I'm pronouncing the name correctly. How do you like the culture at SAS? What do you find that they emphasize and that they encourage? Do they encourage growth in your role?
Oh, absolutely. I love the culture of SAS. I think the one thing that you touched upon was the being able to grow in your role. That was something that absolutely was the theme so far at SAS. Like being able, again, like kind of going back to the earlier question, starting as a data scientist here, but ultimately growing to work on really much bigger projects. I supported some sort of main stage demos that we did at SGF last year, SAS Global Forum, our conference that we do yearly. These are projects that are very front facing, have a lot of impact across the company. The culture of SAS is one that is very laid back, and I think you will meet a lot of good people because here at SAS, I've never encountered an instance where I was afraid to ask someone because I didn't know the answer to something, or if I didn't know how to do something. And these are people who are not within my division. They could be some other team in R&D who develops this product. And I have a question. I never had a hesitation to just reach out directly, and I think that's the thing that you see quite a lot in Cary, right? Being on campus, being able to just like go to someone next door and being able to ask them questions, and so it's been a really good learning experience, and being able to grow quite a bit here at SAS.
If I can just touch on that, Josh, one of the things that I found very interesting is Google in its early days used to come to SAS to see the types of how SAS developed the culture that Dr. Goodnight built, and has tried to emulate that as an R&D, particularly in their R&D world, because as Alex said, anyone is accessible. Alex can reach out to the head of R&D at SAS, and the response will be, how can I help you? That's everyone's goal at SAS, and you'll find that's a common cultural theme at SAS.
It's fantastic. So one of the questions, because we're getting close on time, but I wanted to ask, you had mentioned, Tom, about some of the hackathons, and I know that SAS also has a focus on social good. Alex, you had mentioned Kaggle, pronounce that correctly. For a lot of students, they're trying to also show their wares. They're trying to show the skill sets, and those can be one of the ways that they can build something of a portfolio. Can you talk, is SAS going to be doing another hackathon in the near future? Are there ones, Alex, that you would point out as well?
I can touch on that. We have two types of hackathons. Dr. Goodnight started an initiative a couple of years ago called Data for Good. And here we're focused on sustainability. We're focused on doing things with data that are good for the world. We've been a very active participant, for example, in some of the work that's been done with COVID-19. A lot of that analytic work that comes off the Johns Hopkins database, you'll notice or you may or may not realize it, but it's powered by SAS in terms of the visualization. In terms of the hackathons themselves, in the past, we've always run them once a year. It's actually run out of our team in Sweden. And what we've decided to do this year, which is very different, is we're going to run multiple. We're going to have probably 10 or 15 in 2021. What we will tend to do is, as Alex talked about, we'll try to identify a very specific problem set that we know our customers face, or that we see as a market opportunity for SAS, because SAS is in the process of pivoting from a platform into very specific solutions using the platform. And in doing that, one of the things that we're going to be doing is running hackathons that will be virtual, so you can participate regardless of where it's hosted out of, and help participate in building a team and attacking a particular problem. And the added benefit through Alex's Vector Lab team is, as if this becomes a minimum viable product, we now have a mechanism to take it through our solution factory and potentially make it a product, and it can become a very profitable enterprise for the teams that do in fact win the hackathons. So you'll see us do hackathons in areas like fraud, or in compliance, or in risk, or in retail, or the most recent one that we were talking about was in the oil and gas industry, because these are all new and emerging industries that SAS believes we can use our platform to develop solutions that deliver that. And the hackathons is a great way to engage a much, much larger community than just having to do everything ourselves at SAS, which is what SAS has been known for in the past.
Alex, do you want to add anything to that?
Yep. Yeah. I think Tom, you hit on it perfectly. Is that these hackathons are about not just building out something really quickly with a team, but it's about that community. And so I think hackathons, and I think, you know, doing these sort of activities as part of your portfolio is a great way to get your feet wet, and it looks great for companies. It looks absolutely great. And this is because it shows that, you know, it's not just that you understand, you know, the theory in data science, that you're actually applying it in a very sort of brutal, very real world way, because these hackathons, you know, essentially put you into a very short time frame to be able to put something out there like a day or 2 days later. So I highly recommend that.
So we are right at that 5 o'clock hour. I have put some links in the chat for Data for Good, some of the links to SAS, just general information, as well as career opportunities at SAS. We have taped this, so we will post it probably in the next day or two. And so those of you who want to go back and look for answers, or maybe follow up, you can use it. Again, thank you. Any last words, gentlemen?
Yeah, Josh, one of the things, just to pick up on what Alex said, we'll be publishing, and I'll forward it to you, a page on what our hackathons are, what they're scheduled for. The goal is that they will all be done on Microsoft Azure, because they're our strategic partner, using SAS technologies, and there'll be very specific problems that we're going to go after and try and solve. So as we're putting our plans together for 2021, I'll make sure that you've got that, Josh, and that you can post it to the other members, because Alex is exactly right. Those kinds of experiences are exactly what employers are looking for. It's a problem solving, it's critical thinking, all of those attributes that he talked about throughout this entire discussion are all things that are demonstrated through the hackathon.
Tom, you know, I say this every time, time is the most precious of all gifts. Thank you both for this wonderful gift of time and insights. We really appreciate it. Folks, next week, SIA Partners, working on your resume. Please go ahead and sign up and join us then. Until then, all of you stay safe, stay well. Thank you.
Thank you.
Thank you.